So I have been demonstrating the circuit for this ring oscillator kit that I got off eBay. I actually got 2 of these kits. And so I've been sort of working through, playing around with the kit on a breadboard, drawing up the schematic, figuring out how everything works. What I'm going to do now is build it. But I'm going to do a slight modification, which is the original kit called for 22 microfarad capacitors, and it came with 3 of them. I am not going to use those. I'm going to upgrade to whatever these are, 47 microfarad capacitors. All that's going to do is it's going to make the rotation of the LEDs go a little bit slower. It's because I prefer to have a slower version, that's all. You can see this one came with the red LEDs. Okay, so let's get the schematic out of the way. Turn the soldering iron on and hope that I don't break anything. Okay, first thing that's going to go in here is the resistors. These are 10K resistors. We can tell by the color on them. You can see it's going to be from right to left. That is brown, black, black, brown, and then another black. Brown is 1, black is 0. So 1, 0, 0, and one more 0 times 10 is what it means. It gives you 1, 0, 0. No, that can't be right. That's got to be red. Who cares? It's a 10 kilo ohm resistor. These blue resistors, their color codes are always awful because brown and red look the same. Orange kind of looks like brown. Brown sometimes looks like black. I prefer the beige resistors. Their color codes are usually easier to handle. So these are the 10K resistors going in. And next up we have 330 ohm resistors. These resistors limit current to the LEDs. The way this circuit works is there are 3 sets of 4 LEDs. Each set of 4 LEDs has the current running through them limited by that 330 ohm resistor. If you apply 5 volts to this board, as is suggested, that will limit the amount of current running through those LEDs to about 10 milliamps. And that's 10 milliamps divided across the 4 LEDs, which means each LED is getting about, what, almost 2.5 milliamps through it, so the LEDs aren't run real hard, which is nice. It'll last forever. I'll just make sure that these resistors are flat. And that one wasn't. Now it is. Usually I would have some kind of, I don't know, some kind of helping hands device or something in here to try and help make this a little bit easier, instead of just laying the PCB on the ground. Hang on a sec here. Trying to get rid of the shaking of the camera as a result of the microphone cable bumping into the cable of my soldering iron. Plus I zoomed in a little bit, might help. Not that you're really missing anything here, it's just soldering. Apply heat, apply solder, wait for solder to melt, remove iron, there you go. Those are the resistors. Next thing that's going to go in, we have transistors. Probably should be the next thing to go in. I'll cut the leads in a little bit. You can see on the PCB here that there is a flat edge and a sort of curved edge which mimics the shape of the package of the transistor. Flat edge, curved edge, so you have an easy way to see that you are installing it in the correct orientation. You could be fussy and try to get all these at just the right height, everything straight, right? But it all works the same regardless of what angle your transistor or your capacitor or your resistor is angled at when you solder it in place. The only time maybe you should really care about what angle some component has been soldered into your board is, well, two cases. One is when it's a very tight fit and it has to go in a certain way, otherwise the other components around it aren't going to fit. This is not the case here. Another reason is if you have LEDs, LEDs can be somewhat directional, and you can only see the light, or you see the most light coming out from like just the top. So you want to make sure those LEDs are flat against the PCB, so all the light is coming off the top there. What's next? I'm going from shortest to tallest component. I have these new capacitors, I have these LEDs. The LEDs are going to have to go next. And before I do that, I don't want to use that pair. Come on. Pardon for the shaking. I'm going to bring in my jar of disused junk here. I'm just going to cut these off. Here, you want to see what's in here? Leads and bad capacitors. Now I face it down. I turn it down like this because sometimes the leads go flying. 90% of the time they'll go flying in the direction that I'm of the cutter. They'll fly out this way, but once in a while, like you just saw it, it pings off to the side. You could have a whole betting system in Vegas. Someone just clipping leads off of stuff they've soldered to a board. Which direction is it going to flow or go flying when it gets cut? There. Okay. LEDs are next. LEDs are polarized. We care about this. If you look through the package here, you can see the silver, the two elements. You see how the wires come up, and there's this thin element towards the bottom of the camera, and a much bigger element on the top, sometimes referred to as the anvil. The anvil side is negative, also has a short pin. The tiny side is the positive side. It also has a longer pin. And also these LEDs have a flat edge to them right there on the negative side, which is also reflected on the silk screen of the PCB. So you have a plus sign for positive, and you have this outline of the LED with a flat edge for the negative side. And despite all of the help that the person who laid out this PCB is trying to give me to make sure I put all these LEDs in correctly, I will on occasion still get one wrong. And you don't find out until the very end when you power it up and all the LEDs work except for those two over there. What's going on? And then you look and it's like, ah, jeez. Clearly I was in a rush. Wasn't paying attention. How did that happen? It's not my fault. Curse you, PCB maker. Rabble, rabble, rabble. Alright, so now comes the tricky part. Flipping it over without any of the LEDs falling out. I am only going to apply solder to, or solder, if you're from a region of the world that respects the letter L. Going to solder only one pin of each LED. You'll see why in a minute. It's always interesting, to me anyways, words that I've only ever seen in print, I've never heard anybody pronounce. And suddenly one day you're on watching a YouTube video and somebody pronounces something and you're like, huh, that is not how I was thinking, or how I was pronouncing it in my head. But then at that point it's very difficult to change. I think the one that's been the most shocking to me so far is the word that I say, which is decal, which are those little, stickers that you put on model airplanes and whatnot. And suddenly I heard somebody start saying decal. And I heard another person on the internet say decal, and I'm like, really? It just sounds so weird. And I'm sure decal's probably a correct pronunciation. There's probably multiple pronunciations. But it's just one of those things, it's like, really? That's how you're supposed to pronounce it? I think that probably happens most often. But in kind of reverse when you see French words. It's like, I know what an hors d'oeuvre is, but then you see it spelled out and you're like, really? Who the heck put that H in there? What's this whole apostrophe business? Anyway, so you see what I did there is I only soldered one pin because I knew that they would be crooked. Many, if not all of them, of the LEDs would be crooked. So solder one pin and then come back and reflow that solder with my finger pressed on the LED to push it flat against the board. So now I have all the LEDs perfectly straight. Now I can go back and I can solder or solder everything. And the whole solder pronunciation, I have heard people from other countries pronounce it as solder. Up until I saw the word spelled growing up, I always heard solder. Not that I grew up in an environment with people putting PCBs together. Usually it was running strips of wire between sections of train track, because especially for G gauge layouts where you run them outdoors, and the little clips that hold the track sections together, well, if you leave them outdoors, they can oxidize, even corrode, and you lose your connection to a section of track, and then the next time a train runs over it, it loses power. So you just run wire soldered directly to the track at each connection. Sort of weatherproof a little bit your outdoor train track if you're into that sort of thing. Also heard it in plumbing too. Still kind of freaky to me that, sort of the same thing that I'm using here to put these little components into this PCB is the same thing that can be used to hold copper pipes together to seal them up. except one requires a blowtorch. I suppose I could try and put a PCB together with a blowtorch, but it probably would have consequences that I am not prepared for. Okay, last but not least, we have, well, almost last. Shoot. No worries. There's one thing I forgot. We'll deal with it. Positive and negative, and I think there's going to be enough space here, yeah. These capacitors are still within the footprint on the PCB. They're just a little bit taller than what the original capacitors that came with this kit had. See, so they're going to stick up a little bit. Not a big deal. I'm going to treat these like I do LEDs, which is I'm just going to solder one pin first. Give myself an opportunity to push them flat against the board. Some might argue that's not the best idea in the world, because if one of these blow and it can't allow electrolyte or pressure or whatever to blow out the bottom because it's pressed up against the board, then it's more prone to exploding. I don't know about that. I've only had one capacitor explode on me in all of these PCB, these little tiny soldering kits that I get off of eBay. And that was because the circuit called for 12 volts, and the kit came with a 10 volt capacitor, which I did not realize at the time until I applied electricity. There was a loud pop, and suddenly there was no capacitor on the board anymore. Now I'm gonna have to get that one that just flew out to the side. Congratulations if you bet on perpendicular to the plane of the cutter, you win $5. Okay, last thing I need to solder, why did I just roll that up, is a connector point to hook up power. The first one I did, I put it on the front. I think I'm going to put this one on the back. I think I prefer the connection on the back. So I'm going to come in here and try to apply solder to just one without melting anything, which is highly likely. Yeah, you can see it's way off. So here's the tricky part. I want to reflow that solder and push this connector up against the board. When I do that, this pin over here that I'm going to be reheating is going to get very hot, and it's going to burn me, and I'm going to cry. Here we go. All right. One more. That should do it. Now what's interesting about those pins is they have long pins on both sides, so I could still connect it from the top if I want. Alright, soldering iron off. Nothing more to clip. Let's power it up and see if it works or if it explodes. Like power there, ground there. There it goes. And it's going much slower because I'm using 47 microfarad capacitors instead of the 22s that came with the kit. So which version do you like? Do you like that slower version? Or what do you prefer? The fast version. Different versions for different moods. Oh, that's very nice of them. Look at that. I was thinking, oh, when I was hooking this up earlier, the positive and negative symbols are only on the silk screen, but nope. They very kindly added them to the copper on the bottom side too. So they were thinking, whoever made this layout, they were very kind. I think I like this better. I just think the LEDs could be a little bit brighter. Those 330 ohm resistors should probably be swapped out for like 220, maybe even 100 ohm resistors, just to give a little more brightness to it. Cool. That is the, hang on, what was the name of this kit? I want to make sure I get it right, in case, you know, you want to go out and get one yourself. That's right. It is the LED Water Light Production DIY Suite, Electronic Suite, Triode Running Horse Lamp Part. If you order now, you might get it before June 13th. Actually, when I order kits from China, I find that they arrive within three weeks. Usually 3 to 4 weeks they get here. Sometimes I've had a couple that have shown up within a week and a half. I don't know how I managed that or how they managed it. But anyways, there you go. There's the horse lamp.